In our previous lesson, we talked about relation and function, the domain and the range of an ordered pair, how to determine whether or not a relation is a function, the concept of mapping and the vertical line test, and the function notation with some example problems. If you want to follow up on that video, you can check out the link provided in the description below. For today, we will be talking about the operations of function. For any two functions, f of x and g of x, we can perform all mathematical operations as follows. For addition, f of x plus g of x, when these two functions are added, they produce a new function, and that new function is read as f plus g of x. This becomes the sum, so it is a new function that will be formed when we add two of these functions. So likewise for subtraction, if we subtract g of x from f of x, you have f of x minus g of x. So the new function, which is the difference of the two, becomes f minus g of x. For multiplication, it becomes f times g of x. And for the division, the quotient becomes f divided by g of x. We always do our multiplication and division before addition and subtraction, except in a case where there are parentheses, and we know the rule is that parentheses are considered to be a single term. So you go inside of the parentheses, do whatsoever you can do in the parentheses, then before getting out of the parentheses. But once they are out of the parentheses, you must perform multiplication and division first before addition and subtraction. So let's see some example problems. Number one says, if g of x equals 2x squared minus 5x, find the following. A, g of 2 divided by g of 4. B, g of a plus 1. And let's see our solution. A, we have g of 2 divided by g of 4. So what we're going to do here is, in our function of g of x, we are going to replace x with 2. So in our function we have 2x squared minus 5x. So g of 2 becomes 2 times 2 squared minus 5 times 2. And g of 4 becomes 2 times 4 squared minus 5 times 4. We do our evaluation. You have 2 times 4 because 2 squared is 4 minus 2 times 5 is 10, divided by 2 multiplied by 16. 4 squared is 16 minus 4 times 5 is 20. 2 times 4 is 8 minus 10. 2 times 16 is 32 minus 20. 8 minus 10 is minus 2. 32 minus 20 is 12. So 2 go into itself one time, 2 go into 12 is 6 times. So you will have 1 minus 1 over 6 as your answer. Now we see B. B, what we're going to do is to replace our x with a plus 1. So you will have g of a plus 1 becomes 2 times a plus 1 square minus 5a plus 1. So here what we have here is 2 multiplied by a plus 1. A plus 1 square is a plus 1 times a plus 1. Minus 5 times a is minus 5a. Minus 5 times 1 is minus 5. So you keep our 2 outside and multiply the two parentheses. A times a is a square. A times 1 is a. 1 times a is a. 1 times 1 is 1. And minus 5, a minus 5. You multiply a 2 by the parentheses. So you have 2 times a square is 2a square. 2 times a plus a is 2a. So 2 times 2a is 4a. Plus 2 times 1 is 2, minus 5a minus 5. So you have a squared minus 4a minus 5a is minus a, 2 minus 5 is minus 3. That becomes your answer for B. Let's see another problem. If f of x equals x squared and g of x equals 4x minus 2, find the following. A, f plus g of x, meaning we will add the function of f to the function of g, so this becomes the sum. And B, we will have the difference, g minus f of x. So our solution for A, we have f plus g of x is f of x, which is x squared, plus g of x, which is 4x minus 2. So x squared plus 4x minus 2 is just x squared plus 4x minus 2. You don't have to bother yourself to do factoring or that, so you leave your answer as it is. So this is a new function, and this function is f plus g of x. For B, we have g minus f of x. So this time around you have g, the function of g, which is 4x minus 2 or minus x squared. If you also do your grouping of like terms, you have minus x squared plus 4x minus 2 as the answer, which is a new function, and that function is g minus f of x. Problem number 3. F of x equals x squared plus x minus 6. G of x equals 1 divided by x plus 3. And h of x equals 2x plus 4. Find the following. A, we are to find the difference, g minus h of x. And B, the product, f times g of x. Our solution for A, g minus h of x is simply g of x minus h of x. So we are subtracting the function of h from the function of g. So that becomes g of x, which is 1 divided by x plus 3 is 1 over x plus 3 minus 2x plus 4, 2x plus 4. So here the least common denominator for these two terms is x plus 3. So we have x plus 3. So x plus 3 into x plus 3 is 1. 1 times 1 is 1. Minus. The denominator for 2x plus 2 is 1. So 1 into x plus 3 is x plus 3. So x plus 3 times 2x plus 4 is just 2x plus 4 times x plus 3. So we do our evaluation. We have 1 minus 2x times x is 2x squared. 2x times 3 is 6x. 4 times x is 4x. 4 times 3 is 12. So in our next step, we collect our like terms. Minus is multiplied by the entire parenthesis. So each of the terms in this parenthesis must be multiplied by negative. So this becomes negative 2x squared. This becomes negative 2x squared. So negative 2x squared minus 4x plus 6x is 10x. So it becomes minus 10x. This is minus 12, but you have 1 outside here, so it's 1 plus minus 12, which is minus 11, divided by x plus 3. So this becomes your answer for g minus h of x. B, the product of f times g of x, which is just f of x times g of x. Our f of x is x squared plus x minus 6, and g of x is 1 divided by x plus 3. So what we do here is in this parenthesis we have a quadratic expression. So we factor this quadratic expression. So here, this is a quadratic expression of the form I term as unity, because the coefficient of the quadratic term is 1. So we call that unity. So for unity problems, let's see if we can find a number such that when we multiply those numbers, two numbers, we will find the constant term, and when we add those same two numbers, we have the coefficient of the linear term. If that is possible, then we can just simply factor. So in here we have minus 6, which is the constant term. So two numbers we can multiply to give us minus 6, and when we add them, we have positive 1, 3, and negative 2. 3 times negative 2 is negative 6. 3 minus 2 is 1. So it satisfies that condition. So what we do is just open our parentheses, two brackets, and we say x plus 3, x minus 2. Simply so. So we have x plus 3, x minus 2. So we use that in place of this quadratic expression. We have now is x plus 3 times x minus 2. We know that this expression multiplied by 1 is just this expression. So we have this now divided by x plus 3. We see that x plus 3 and x plus 3 are common. So they will cancel out themselves. Then you will be left with x minus 2, which becomes your answer, your product for f of x times g of x. Number 4. F of x equals x squared minus 4 and g of x equals 1 divided by x minus 3. Find f times g of x. B. Find a set of domain. Solution. A. F times g of x. So we are finding a product of these two functions. So we have x squared plus 4 times 1 divided by x minus 3. So this is just x squared plus 4 divided by x minus 3. Then B, the set of domain. The set of domain is x is a set of all real numbers such that x is not 3. Why x is not 3? Because if x is 3, in this denominator you have 0 to make this term an undefined term. So we say that x cannot take on the value of 3, but it can take on the value of any real number. So this is the domain of this identical function.